So, a brand new topic. I love vectors. I think it's a really nice topic. Okay, we're going to have several goes on this because I think these can get quite tricky. So, I think it'd be a nice juicy thing to get our teeth into over the next couple of weeks. So today's lesson is just going to lead you on to a fairly easy Hegarty, hopefully quite a quick one. And I wanted us to do this one anyway. It's important to start somewhere, but I was conscious of what George was just saying. I was conscious that I gave you quite a bit of reciprocal graph work to do. So I thought if today's was quite quick for you, you could go back perhaps and have another go at that, or a first attempt at that one. So what is a vector? A vector is has both size, which is magnitude, and direction. Okay, so that would be a vector. Okay, it's got a length. It's got a length. It's 3 centimeters long, and it goes from A to B. Now think of it as a one-way road. Okay, as you go from A to B, you're going down the road the right direction. Now the way that that vector can be described is two ways. And note how the points are capital letters. So it could be described as going from A to B, and you put an arrow over it, so that's pretty clear. You're going from A to B. Or it could be given a lowercase letter, for example, A. Now, if we are writing it by hand, we do a little dash underneath it to show that it represents a vector. If we were typing it, so textbooks will have it in bold type, a lowercase a. Now, for the purposes of Mr. Hegarty's answers, clearly it's not easy to go and put a little dash underneath. So he's just using normal lowercase letters. So let's, what I've done here is just one simple little example, okay? We've got a parallelogram there, okay? You've got all the various uppercase points on that parallelogram. And we've gone and included two actual vectors. Going from D to A, we're calling lowercase a, and going from D to C, we're calling lowercase b. Okay, now we're given some further information on this parallelogram. We're told that AG equals GB. So A to G equals G to B. So what you would do in an exam, or when you're answering a question, just go and put in a 1 there and a 1 there, because you're just reflecting the fact that going from A to G is the same distance as going from G to B, because AG is the same length as GB from the question. Now, they're also telling us over here that the ratio of B to F to the whole length, B to C, is 1 to 3. So if we go and make that 1 there, that shorter length B to F being 3, being 1, as we're going all the way from B to C is 3, the bit from F to C must be 2. Okay, just going over that again. B to F is 1, a ratio of 1. B to C is a ratio in its entirety of 3. So the F to C bit must just be 2. And just be clear in your mind, I'm not saying for a minute that the length of B to F and G to B are the same. These ones are different ones. It's just a little working on our diagram. So as we go down this road here, or we go along this road here, we're just remembering where G and where F fall respectively on their lines. So what questions we'll be asking you to do is to describe all these ones I've done over here, like from A to D or A to C, but in terms of little a and little b. Okay, so let's just go and put what we know onto the diagram. Because it's the parallelogram, going from D to A is exactly the same vector as going from C to B. They are equal in length and they are equal in direction. So labeling up our diagram, we can just go and say that going from C to B is also vector A. Now, going from D to C, that's just going horizontally that length. So going from A to B is also the same vector as vector B. So I'm just popping a little b up there to remind me that as I go from A to B, that is also a B. So I'm just, again, just be clear. So we've got the arrows. So going from A to B is a little b. Going from D to C is a little b. Going from D to A is a little a. Going from C to B is a little a. So let's start trying to describe all these on the left, on the right rather, in terms of little a and little b. So going from A to D, well, I'm going down this A road the wrong way. It's not a vector A. A vector A would take me up here. It would send me off in that direction. So going from A to D, just think of if you're going down the road the wrong way, that's just going to be a minus A. Now, going from A to C. Now, we need to do a working here, okay? You've got to think about it as going from Andrew's house to Chris's house, okay? And you're only allowed to go on the A and the B roads. So it would be great if you could go and cut straight across there to go from A to C, but that road doesn't exist. It's just a pathway with lots of stinging nettles on it, okay? So you're going to have to go from A to C. Now, you need to explain to the person who's marking the question how you've decided to do that journey. Now, I could go via Bill's house. I could go A to B, B to C, or I could go from via Dave's house. I could go A to D, D to C. It doesn't matter. You will end up with the same answer. So I'm going to choose to tell the examiner that the way I'm going to do it, right, I'm starting off at Andrew's and I'm going to Dave's, and then I'm going from Dave's to Chris's. So notice how that is. It's still in terms of uppercase with arrowheads. Okay, now you then say to yourself, are we now in a position where we can give a final answer in terms of little a's and little b's? Well, I am, because I know what A to D is, it's a minus A, and I know what D to C is, it's a B. So I can then go and give my final answer of A to D being minus A and D to C being A plus B. I'm going down that the right way. Now, note, you never go and mix and match. I started off with uppercase with an arrow. All of that bit there is uppercase with an arrow. And then at that point, I've gone and turned to lowercase. Okay, so never mix and match. Don't have a bit of capitals and arrows and lowercase stuff. Right, how could we describe going from B to D? Well, I'm going to do that by going from B to C, Bill to Chris's, and then from Chris's to Dave's. Okay, now Bill to Chris's is going down this A road the wrong direction. So that's a minus A. And C to D is going down the B road in the wrong direction. So that's a minus B. Now, going from A to G. So we're going from Andrew's to Giles's house. Okay, now what you've got to go and do here, the A to G is half of A to B. So just go and make that clear. A to G is half of A to B. Okay, clearly G is halfway along, so it's halfway along. Now, what do I know about AB? Well, I know that AB is the vector lowercase b. So I can then go to give my final answer of it being half B. Now, what about going from Andrew's to Fiona's? Okay, now I could go Andrew to Dave, Dave to Chris, Chris to Fiona. That would be fine. It would give me a correct answer. But I'm going to go a quicker way. I'm going to go Andrew to Bill, Bill to Fiona. Andrew to Bill, that's Bill to Fiona. Okay, now Andrew to Bill is easy. That's just a B. And then be careful with your Bill to Fiona. We're going a third of the way down that road, 1 out of 3, but we're going down it the wrong way, so it's going to be a minus a third A. So I think that gives you an introduction. Obviously, feel free to watch this back on a recording if you're still not clear. And obviously, feel free to watch Mr. Hegarty's video. But I would like you, please, and it won't take you long, all right? It's not as complicated as the one I've just done. It's not as complicated as the example I just talked you through. I would like you to go and do 629, please. I think what I've just talked you through might be more of the level we're moving on to next lesson, okay? So go and do 629. It wouldn't surprise me at all if some of you go and do it in a few minutes. let me just, yes, so let me just, I took a sample of questions of it, so you can just see it. So this is an example of question 3. We've got to describe going from C to A. All right, we're going from C to A. All you're going to do there is say you're going from, the workings isn't going to allow you to do the bit I'm writing. All right, but if you're writing it down on paper, this is how I would like you to do your workings. To go from C to A, the only way we can go is from C to D and D to A. Now, the only reason you can only go that way because you haven't been given the information about that road there. Okay, so to go from C to A, we're going C to D, D to A, and then you can go and say, right, that's going down that one the wrong way, so that's minus 2p, and then we're going down that one the wrong way, minus 3q. So I think for the purposes of Hegarty, you're going to say minus 2p, minus 3q, no dashes. Okay, so that's how we go from C to A. Right, let's do an example of question 8. Now, this looks a bit more common. It's a hexagon, so you've just got to appreciate what's going on. They're calling that 5A, that's 5B. Going from O to E is therefore an opposite of that one. So that's a minus 5B. I don't know if I need it yet, but I'm just filling in what I know. Going from O to D, that's a minus 5A. All right, it's exactly the same length, but in completely the opposite direction. So now I can go and describe how to go from O to E. Well, it couldn't be easier, could it? That's just going to be a minus 5B. So minus 5B, when you write it down, hang on, I'm just doing recording. Okay, so minus 5B, but you can't do the dash in your final answer, but in your workings, you've got the little dash underneath, please. And then finally, on this one, again, you've just got to be aware of how we're going to go from D to F. To go from D to F, we're going to go D to O. So you're going to go up there. Then you're going to go down there. So you're going to add on an O to E. And then finally, you're going to do an E to F. Okay, so you've got to zigzag your way there. So you can see what these are all. So D to O, can you see that D to O is exactly the same vector as O to A? So that is a 4A. O to E, that's obviously going 4B, but in the opposite direction. So that component is minus 4B. So minus 4B. And then going E to F, well, that's another one of these, isn't it? It's going at the same angle, it's the same length, so that's another 4A. Now, this is the first time we've come across one of these. When you get to this situation, it's just like normal algebra. You just gather like terms. So 4A plus 4A is 8A, and then 8A minus 4B would be your final answer. So that's it, folks. What I want to do, I'm just going to have a quick cup of tea. Can we say that, Raoul, I will therefore call you at 10:20. Olivia, yeah. I will invite you at 10:25. Emma at 10:30, and then Tracy at 10:35. Obviously, I'm going to stop this recording now because I don't want to record those, but you'll be able to play this one back. Okay, cheers, guys. Bye. I'm just recording, hon. Just trying to stop the recording.